I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss special products while multiplying the polynomials. The topics which we are going to cover are listed. We'll understand what is squaring of binomials, x plus y whole square, x minus y whole square, ax plus by whole square. We'll have some practice questions. We'll model special product a plus b plus c whole square. And then we'll take our product of sum and difference, which is x plus y times x minus y is equal to x square minus y square. Now, based on this, there are many multiple choice test questions in competitive exams. So we are going to understand the strategies to answer these questions in less than a minute. So applications to simplified products will have applications based on a square plus b square, where the formula can be derived as half of a plus b whole square plus a minus b whole square. And then we'll also derive the formula for a plus minus b whole cube. So let's begin with the very first example, which is expand and simplify x plus y whole square. So x plus y whole square means we'll multiply x plus y by itself. So when I do so, what do I get? I'll apply the distributive properties. First multiply with x both the terms, x plus y, and then with y. And then we are going to add the like terms. Let's see, what do we get? When you multiply by x, you get x squared plus x times y is xy. X times y is xy, and then we'll multiply by y, we'll get plus yx, and y times y as y squared. Combining the like terms, we get x squared plus 2xy, these are like terms, plus y squared, correct? Now let us also model this particular product using one of our modeling methods. You could use algebraic tiles or rectangles. So let us take a rectangle in this particular case. So it is basically a square which has two sides. One of them is x plus y. The other one is also x plus y. So let me make a square here. And in this square, we have the sides which are x plus y and x plus y. So let's say this is x plus y, and here also we have x plus y. So let's say x is that long and y is slightly shorter. In that case, we get a tie which could look like this. Now, when you multiply x and x, we get x squared. When you multiply x and y, we get xy. Multiplying y with x is also xy, and y times y is y squared. Clearly, from this tile itself, we get our result, which is x squared plus xy plus xy plus y squared. Combining the like terms, we do get x squared plus 2xy plus y squared. So in short, we can write down a formula, which is x plus y whole square is equal to x squared plus 2xy plus y squared, correct? So that becomes a formula which we are going to use many times in coming examples. Now let us explore further what happens when we have difference x minus y whole square. So the example 3 is expand and simplify x minus y whole square. As we had seen earlier, we'll multiply x minus y by itself. When we do so, we'll get x squared minus xy. So what have I done here? I have multiplied with x these two terms, and now I'm going to multiply with minus y, same terms. So minus y times x will be minus yx, and minus becomes plus, we get plus y squared. Now, if we combine the like terms, which are right there in the center, we get minus 2xy. plus y square. So it is sum of the squares with minus 2xy. Perfect. Let us model this with algebraic tiles. Now we have a negative number, so in that case, we'll take positive numbers with green color. Let's say this is green, which is x for us, and minus y will take blue. So let's say this is blue, which is minus y for us. Now, on this side also, let's say width, we have x and minus y. Now, when you combine this, you get what? When you multiply like terms, you get positive. So this will be a square, which will be x square. Clear? When you multiply positive with negative, you will get negative, and therefore I'm using a blue color here. And what you get here is, let me write down this as xy, but this is negative, right? Now, on multiplying with minus y and x, we are again going to get negative. So that is how we could write minus xy. But when you multiply two negatives, you get a positive. So I'd like you to actually look into this and understand what are we getting into. So what we get here is two negative xy's, and we do get positive y squared. The reason for positive y squared is that two negatives are multiplied. Perfect. So let me summarize what we did here is we are now doing multiplication with positives and negatives, right? So if you, let me make a matrix here to understand the whole process. So let us say we are multiplying positive with negative. The operation being done here is multiplication. In that case, the same signs result into a positive number. However, the different signs, positive and negative and positive, will give you negative numbers, and that is what we are trying to show here. So from this, we could write down the result as x squared minus 2xy plus y squared, which is exactly same as we got earlier. So we could use algebraic tiles, or we could model the situation using rectangles. Now let's move on and take the next example. Example number 5. You need to expand and simplify 2x minus 3 whole square. You can now pause the video, answer this question, and then check with my solution. So let us start by writing the binomial 2x minus 3 product with itself because it is a square, and now expand using distributive properties. First, we'll multiply with 2x. What do we get? We get 2x times 2x. So let me write here 2x times 2x, which is 2x whole square. And then we get negative 3 times 2x. You could write them in either order, right? Now multiply by minus 3 both the terms. So if you do that, you get minus 3 times 2x and minus 3 times minus 3. So 2x and 2x, when you multiply, you get 4x squared, and here you get minus 6x minus 6x minus 3, and minus 3 gives you plus 9, and that results into 4x squared minus 12x plus 9. Perfect. Now, I would like you to check this result with the formula we just learned. And the formula was, if we have something like a minus b whole square, it could be written as a squared minus 2ab plus b squared. So I like you to verify this result using the above formula. Perfect. That is our answer. Okay, let's take up the Next example, which is ax plus by whole square. So let's rewrite this, ax plus by whole square. It really means we are going to multiply ax plus by itself. Perfect. So that is what we do. Then we get ax whole square plus ax times by, and then multiply with by, we get by times ax plus by whole square. Correct? When you multiply ax whole square, you get a square x square. These two terms are common, so we get 2abxy, and we have b square y square. Do you see that? This is also a very important result which you should really make a note of. Perfect. So if you have a general expression which is of the form ax plus by whole square, you almost get the same thing, right? Think about ax as just one term, so the square of that, and by square of that, and in the middle twice both these terms. Well, let's get back to the formulas. Here in examples 7 and 8, the question is expand using the formula 2x plus 1 whole square. Now let us try to understand exactly how do we use formulas to write the answers quickly. So let me rewrite the formula once. Let's say we have x plus y whole square, then it really means it is x square plus 2xy plus y square. However, if we have x plus is changed by minus, then this minus gets changed by minus. Remember, square of a negative term is always positive, and that is why this is positive. Perfect. So, in the given situation, which is for us 2x plus 1 whole square, what we are going to do? We're going to write down the square of the first term, which is 2x, plus 2 times both the terms, which is 2x times 1, and then square of the second term. So what we get here is 4x squared, plus when you multiply this, you get 4x plus 1. So that becomes your result. Is that clear to you? So it is that simple. Again, let us once again try to do example number 8. At this stage, I would like you to pause the video. Answer this particular question and then match with my solution. 2x minus 5y whole square. So when you square it, first term square, which is 2x whole square, minus twice product of both 2x and 5y, plus the square of the second term, which is 5y. So what you get here is 4x squared and minus 2 times 2 is 4. 4 times 5 is 20. So we get 20xy plus 5 squared is 25 and y squared. So do not forget to square both 5 and 2 in this case. So I hope you got the same answer. Let's move on and see another example. Wow. This time we are going to multiply a plus b plus c by itself, and that is the square of this. Okay, so one way is to model the situation and the other way is to just expand and multiply. Let's do with expansion first. So that really means I'm going to multiply a plus b plus c by itself, a plus b plus c. So that means first I have to multiply all the terms by a, right? So all the terms by a, 3 terms. So that means we are heading for 9 terms. Okay, so let's do it. So we get a square plus ab plus ac. This is what happens when you multiply with a all these 3 terms, right? Now let's do it with b. So we get ba plus b square plus bc. Now with c, we get ca plus cb plus c square. Now, do you see some common terms here? Well, a square plus b square plus c square, nothing is common there. However, we do have ab and ba. Now, these are same. So we could write this as 2ab, right? Similarly, we do have the terms which is AC and CA. So we could write them as 2AC. And the last term CB and CB are also same. So 2BC. Right. So that gives us the formula which is A square plus B square plus C square plus twice product of individual A, B and C, right? Okay, so that is how we could really do it. Now, can you model this situation? Interesting. Let's see how we could do it. Well, definitely, it is also a square. So let me make a square and we'll make the dimensions of this square as a plus b plus c. So let us say this is a for us, right? So let's say this is a for us and then this is b for us. I want to take slightly different dimensions. Let's say this is B and this is C. Now, this is on one side. The other side also will have A, B, and C. Now, when you multiply them, what do you get? Let's figure this out. Let me write A, B, and C on this side also. So, when you multiply, A times A is A squared. A times B is AB. A times C is AC. When you do it with B, you get again AB, B squared, and BC. The third row is AC, BC, and C squared. So clearly, you do get the 9 terms. 3 times 3, 9 terms, and they're exactly same. As you can see, we have the term which are squares, a square, b square, c square, that takes care of these. And then the other 6 terms is the combination of AB, AC, and BC. So you could also use the model to explain the whole situation. So I hope that makes things very simple and easy to understand. Let's move on and take next example. The question here is, now we are moving to difference of squares which you get when you multiply sum with the product. So the example here relates to product of sum and difference. X plus y times x minus y. What you get is x square minus y square. Let us verify this. So we have example 10 which says expand and simplify x plus y times x minus y. So let's multiply and check. So we have x plus y times x minus y. That should be equal to, first, let's multiply with x, and that will give us x squared minus xy. Now let's multiply with y. When you do so, what you get? X, y, and y squared with a negative sign. Okay, so let's write it down. So we get plus xy minus y squared. Clearly, the center two terms, they cancel away, right? They are complement of one another. And what remains is difference of squares of x and y. So that's the formula, which is extremely important to remember. And it is very helpful in solving many questions within a minute. So it's a shortcut formula which you could always apply in related questions, especially when you get multiple choice competitive exam test questions. Now here is example 8, which is expand and simplify. So we have 2x plus 5 and we need to expand. So first we'll multiply with 2x, so we get 4x squared. Then 2x times minus 5 is minus 10x. So what we have done here is multiplied both the terms with 2x, and now we are going to multiply them with 5. So when you multiply by 5, you get 5 times 2 is 10, so you get plus 10x, and 5 times 5 is 25 with a negative sign, simply because we have plus and minus 5. Now the center two terms cancel away and you get 4x squared minus 25, which you can see is same as 2x whole square minus 5 squared. So that confirms our formula. Perfect. Now let's move on and use this formula. Here is an application for you. Very interesting. Question 11. Shortcut method to find the product 21 times 19. Now, in many tests, we are not allowed a calculator. Then how will you do 21 times 19 or similar products? Well, the idea is that we could write 20 as 20 minus 1, and we could write 20 as 20 plus 1, and 19 as 20 minus 1. Now, that reminds, we could write this as 20 square minus 1 square. Well, this is our difference of squares formula, right? So let's write down the formula once again. We just learned that x plus y times x minus y is difference of squares. X square minus y square. That's what we applied. Do you see how easy it is? Now 20 square is 400, right? So 20 square is 400, not a big problem. We could always write this. And 1 square is 1, so 399 is our answer. So we do get this answer in few seconds. Do you see that? So definitely less than a minute. Next example is slightly bigger numbers. Expand and simplify 125 times 75. Well, I would like you to pause the video and answer this question. 125 is 100 plus 25, right? And 75 is 100 minus 25. And that should be equal to 100 square minus 25 square. And that is 100 square means 100, 100. Minus 25 square is 625, which most of us know, right? It's not that difficult. So you have to learn strategies to find squares with such numbers which end with 5. That is very handy at times. So when you take away 25 from 100, you get 75. You have 9 here, take away 6 is 3, and then you're left with 9. So you get 9375 as your answer. Do you see that? It is so simple using difference of squares. Now here is an application question which says radius of a 4 centimeter circle is increased by x centimeters. So we are increasing radius by x centimeters. Now, how do we do this question? Okay, so we have two squares, two circles. Let's say we have a circle here, okay, and then the other one, which is kind of increased circle. So, okay, let's make another circle. So let me just select the shape of a circle and make one more here. So we have another circle here. So these are two circles. We need to find the area in between the two circles. That's the question for us. Is that clear to you? So we are saying in this particular case, radius of 4 centimeter, this is 4 centimeters, is increased by x. So that means it becomes 4 plus x. Write simplified expression for the increased area. So that is the question. So the increased area for us is this area. Can you pause the video now and answer this question? I hope the question is absolutely clear. Well, we can write down the area of each square and take the difference. That could be done. And what is the formula? Let's write down the formula for circle area. So area of a circle is pi r square, where pi is equal to approximately 3.14. So for all our calculations, we could take 3.14 as the value of pi. Now it says write simplified expression for increased area. So that means the difference of 2, right? Now will be what? So we get this, let's say this is circle A1, you could say C1, and the area A2. So the increased area will be, let's write down, increased area will be difference of the two, a2 minus a1. And as we know, the change is difference of these two, and the formula is pi r square. Well, that is difference of squares, right? So we could write this as pi of radius in the second case is 4 plus x whole square minus, in the first case it is just 4. So we get our formula, and that is it. Now what we could do here is pi is kind of common, and we are left with something square minus the other squared. Perfect. So we could write this as pi, and within our brackets we have difference of squares, which is 4 plus x whole square minus 4 square. So difference of squares we could actually expand and simplify, or we could also write down the formula of difference of squares. But in this case, it is easier to expand and simplify. So we'll keep pi outside. And when you expand this, you get what? You get 4 squared, which is 16, plus 2ab, which is 8x, plus x squared minus 4 squared, which is 16, right? 16 and 16 cancel, and with pi you get the value, which is, so we'll cancel 16 and 16 first, that is minus and plus, and we get 8x plus x squared. So that becomes a simplified expression. You may or may not take pi outside, you could work with it together. Perfect. So we have done part A, which is writing the increased area expression. Now, part B for us is, let me change the ink for part B, which is evaluate this when x is 6. Since the space is limited, I'll continue from here. Just substitute 6 here. So we get pi, which is 3.14, 8 times 6 plus 6 square, right? So we get 48 plus 36. That is what we get, and you can add them and multiply by 3.14. So we get pi, which is 3.14 times, when you add this, 6 times 8 and 6 is 14, which is 4, and then 1, which is 84. So you can now approximately multiply, well, round it to like 90 times 3, you get approximately 270, right? So you could approximate your answer if the calculator is not allowed. But if the calculator is allowed, we could actually multiply and see our result. So I'm multiplying 84 by 3.14. And what we get here is approximately 263.7. So it is actually equals to 263.7. Perfect. So that is how you could get this answer. So I hope the steps are absolutely clear. Let's move on and take some more application questions. Example 14. Prove that a square plus b square is equal to half of a plus b whole square plus a minus b whole square. Now, how can I do that? Well, this is a very good question. Let's try to understand. So we have a term which is a plus b whole square. So if I apply the formula, I get a square plus 2ab plus b square, right? How about a minus b whole square equals to? Well, in that case, we get a square minus 2ab plus b square. Now, what happens when we add them, right? Since we have the term here plus, let's add these two. So when you add them, what do you get? Well, on the left side, we get a plus b whole square plus a minus b whole square. And on the right side, the center terms cancel. We get 2a square plus 2b square. Correct? As you can clearly see, these two cancel away, plus a negative sign. Well, that clearly shows that we could take 2 common, and we do get a square plus b square. Now we need to find what is a square plus b square. So we'll divide by 2 on both the sides. And what we get here is a plus b whole square plus a minus b whole square is equal to a square plus b square. And that is the formula which we wanted to derive. Is that clear to you? Now this is an excellent formula which we have just derived, and in many multiple choice questions, direct application of this formula can help you nail the competition. So here is how we are going to take this up. Now once again, I'd like you to understand this. A square plus b square, that is when you are adding squares, sum is half of sum of squares plus difference of square, correct? So remember this, and then we'll apply to this question here, which says calculate what is 37 square plus 33 square without calculator. So what did we learn here? Well, we learned a formula which was a square plus b square equals to half of, you have to add a and b, right? Square that, plus you have to subtract a and b and square that. That is what we learned, correct? This is the formula which we learned. A square plus b square is half of a plus b whole square plus a minus b whole square. So we're going to apply this formula now. Perfect. So what is a and what is b in this case? Well, in this particular case, you can say that a is 37 and b is 33. Clear? So let's do it. So what we have here is a square, which is 37 square plus 33 square, is equal to half of 37 plus 33 whole square plus 37 minus 33 whole square. And that gives you half of, when you add 3 and 7, you get 10, 1 there, so 70 square plus difference is 4, 4 square. Now you could do half of 7 square is 49, so you get 49 and 2 zeros for this, right? Not 1, 2 zeros, plus 16, 4 square. Add this up, you get half of 49, 16, correct? And now you do half of this, dividing by 2, we get 2, 4, 8 goes 1, and then 8. So we get answer 2458. See how quickly we could get the result. It was not an easy calculation. Without calculator, it might take much longer. So this formula really helps. So I'd like you to pause the video, grasp this concept, and then move forward. Now here is another very important concept. We are going to explore more about the cubes, but here we're just introducing you to the cubes, a plus b whole cube and a minus b whole cube. So let's begin with finding out what is a plus b whole cube equals to. Well, I could write this as a plus b times a plus b whole square. Well, we know what a plus b whole square is, so I could write that as a square plus 2ab plus b square, right? So we used one of our known formulas, and now we'll apply the distributive property, getting the 6 terms. Perfect. And then we'll get the formula. So a times a square is a cube plus 2a square b. We're multiplying with a all these terms plus ab square. Now with b, when you multiply, what do you get? We're going to do the same operation with b to get our result. So b a square b, is good practice to write them in order, right? It becomes simpler to combine the like terms. 2ab square plus b cube. So we get our 6 terms. Now combine the like terms. Now in polynomials, whenever you write the terms, it is good practice to write in a particular order. So decreasing degrees, right? So highest degree first. look for a square b, right? So we have the term 2a square b right there. Another term a square b is there. So we'll combine these two terms to write this as 3a square b. And now we are looking for a terms, ab terms, right? So ab, a, b square and 2ab square gives you 3ab square. And then the term left with us is b cubed. So we get our formula, which is a cubed plus 3a square b plus 3ab square plus b cubed. Perfect. So that is how you get this formula. Now, can you tell me how do I get formula for a minus b whole cube? Well, simply, if I replace b with minus b, I should get my result, right? So I'm going to do that. So I'm going to replace b with minus b. So we get a cube plus 3a square. And I'm writing here, instead of b, I'm writing minus b, right? And so we get plus 3a. And then again, instead of b, I'm writing minus b square. And once again, with b cube, I'm going to write minus b cube. Perfect. So that helps. So what we get here is a cube. When you multiply negative with positive, you do get a negative term. So we get minus 3a square b. Negative square becomes positive, so this term remains positive. Here we get a negative b cube. Do you get the idea, right? So instead of expanding and simplifying, we applied it to the same formula and we actually got our common formula, which is a plus b whole cube can be written as, let me write down here, a plus b whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. However, if we have a negative term as minus b, then wherever we have odd powers of b, those terms becomes negative and we get our result. Does it make sense to you? So that is how we are going to get the formula. So I hope this formula is absolutely clear. Make a note of this. And with that, we come to an end of this particular video where we have learned many formulas. Let's write them down here. So we have x plus y whole square as equal to x square plus 2xy, the product of these two multiplied by 2 plus y square. Whenever this is negative, in that case, we get a negative term here. Perfect. Now, in case we have cubes, let me write down first x plus y plus z whole square. In that case, it is sum of the squares, all the three, right? And then twice product of two combinations, xy plus yz plus xz, correct? So that could be easy way of remembering it. Now, we also talked about the cubes, which is x plus y whole cube. So in that case, it is x cube plus 3 x square y plus 3 x y square plus y cube. And in this case also, if there is negative, odd powers of y becomes negative and you get your result. Another interesting formula is right there before you. So you should use this formula and the one which is difference of squares for shortcuts to many multiple choice questions. So I hope with this you understand the concepts of special products and also see how they could be applied to solve many application questions. I hope you find it interesting and useful. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'll be great. Thanks for your time and all the best.